So if we think back then to the overall kind of overlook of Mars's geological history,
Yeah.
there certainly were times in which it seems like it could have supported life, or at least there were environments that were habitable to what we can like Earth organisms.
Yeah.
There are, very habitable.
Yeah.
It's not like some of them weren't even that extreme, seemingly.
Yeah.
Extreme in the sense of what we consider extreme for our
Yeah.
biology.
Yeah. Like in the Noachian, like these
Yeah,
lakes,
particularly
and rivers
early in Mars's history.
Yeah.
And so you have to think so that doesn't necessarily mean, of course, that life existed there.
No.
There's a big jump between a habitable environment and an actually inhabited
Yes.
environment. And we don't really know exactly what the kind of causal relationship between the two is. Not causal relationship, but whether there is always, if you have a habitable environment, there's always life there.
Yeah.
It's inhabited.
So we don't know. That's exactly right. Like that's it's almost like a hypothesis that needs to be tested.
Yeah.
Like a habitable environment is inhabited.
Yes.
That's like a statement that you can test.
Yes, it is.
Like using Mars.
And yeah, exactly. So Mars may have had environments that could have supported life, but life never developed there because you actually need a particular type of volcanic vent or something to start life off, as we know it.
Yeah.
And consequently, potentially we could have a nice, lovely, habitable planet sat there with absolutely nothing growing in it or living on it, no life at all.
Which would be...
And that's because we don't know much about the origins of life. That's kind of the problem.
That's kind of the problem. But this is the cool thing, is that Mars
is a great test.
Is a great test, and it will hopefully let us. It will hopefully answer some of these questions about the origin of life. Because either answer. So either answer, the first being that Mars had habitable environments and had life. I mean, that's a massive discovery for like a huge number of reasons. One of which is that now it tells us if you can find out that origin of life was separate from the origin of life on Earth, that tells us two planets that had those kind of conditions early in their history, life started on both. And we know that life started like super fast after the formation of the Earth, really.
Yes.
Like, what's the earliest evidence of life on Earth?
Well, it keeps getting pushed back.
It does keep getting pushed back.
It was like 3.8, but it might even be 4 point something.
There was that evidence.
Zircon crystals.
Zircon crystals, yeah.
So it might even be. I mean, there was some stuff that might even predate the late heavy bombardment and all sorts of stuff like that.
Yeah, I mean, if that's the case, then it's almost just like as soon as there was a planet there, life is basically happening.
That's like 4.5 billion years old.
Yeah.
So if it might have taken a few 100 million years for life to develop on Earth,
to the point where it's like life that we'd recognise as life.
Life that we'd recognise as life, not just kind of proto, prebiotic chemistry.
Yeah. And then so if that was also happening on Mars at the same time, and remember, like, the conditions were very similar. So,
seemingly.
So yeah, it seems like they were. So it's not too much of a leap to suggest that the same processes should have been happening. I mean, the planets formed from the same material. They would have had the same
roughly
inventory of material, right?
Yeah. Well, yeah, slightly different.
Just slightly different?
I think they. Well, that's the reason Mars is slightly different to Earth, right? It's because it gets. I can't remember exactly, but some of
there's
a
gradational sort of change in the material in the
you
disc.
get more gas as you go far out and stuff.
Yeah, you do. But Mars and Earth were very close to each other.
They were, they were.
It's my understanding that they had.
It's roughly
they are
the same
thought to have
material.
formed from the same starting material.
Yeah, more or less. Yeah.
More or less, yeah.
Yeah. I think that's true.
So if we find life there, basically it suggests that. I mean, it suggests that it's everywhere, basically, doesn't it? If we find life there that started separately, that has its own origin.
Yeah. That's the key thing. So
yeah,
that's another great thing about Mars, is that you can look at if you do find a biosphere there, and this is under the circumstance that there is life in this habitable environment. If you find a biosphere there, if it has a separate origin of life from the Earth, then you can probably say, when you think about the universe in general, if you have habitable planets, you probably have life.
Yes. At least like microbial life. Simple life is a process that is very common. Yeah.
Very common. Very, very common. If it developed on those two planets in those periods of time. Separately. If, however, it may be that life doesn't have a separate origin. So we know that there are material exchanges going on between the Earth and Mars that have gone on for ever since they were both formed.
Yeah, and presumably in the time that Mars was really wet and warm way back in the day,
Yeah.
there was a lot more material flying around the solar system.
There was the later bombardments during that period.
Yeah.
So potentially Mars, there's lots more crap basically being knocked off Mars. And we know that organisms can survive long times in space, especially if they're kind of trapped deep in like a meteorite or something. They could then survive
atmospheric
re-entry and everything.
And this is stuff that's all been tested through experiment.
Yeah, and then seed Earth. Basically, Mars seemed to be maybe possibly habitable before Earth was. I'm not really sure about that, but potentially. So it could go both ways, but maybe you could have had Mars seeding Earth with life, or
so
the other way around.
Yeah.
So they may actually be related, the two biospheres you find.
Which again would be like unbelievably scientifically valuable.
Yes.
Because it's almost like you've run another evolutionary experiment with the same starting point.
Yeah.
On two different planets, so you could look at what's happened on Mars and sort of compare and contrast it with here and everything. So I mean, it's hard to overstate like how much of a significant discovery finding life on Mars would be.
But then there is. I can't remember. Did you say that there's obvious if there's the other scenarios that if there's no life on Mars?
Yes, no, I haven't gone into it yet.
Okay,
but
yeah. If you want to.
Yeah. I mean, that's also like a massively significant result. If we find that Mars was full of like habitable environments, very similar to the Earth,
but just empty.
I mean, but that would take a long time to get to the point where we could convincingly say that was the case, probably.
Yeah.
But I think it would happen. It would
largely.
It would look more and more likely the more and more places we look, and the more and more techniques we use to look. It's like if there was life here, we should be seeing some evidence of it. And if we can get to the point where we think that there was definitely no life in those early periods, then that tells us that there was something different about the Earth. That despite the fact that the two planets looked so similar at that time, and seemingly had the same kind of
there's some extra requirement.
There's some extra requirement, something that was happening on Earth that wasn't happening on Mars.
Probably due to something to do with the origin of life has to form in a very specific type of environment. Like I was saying, a type of volcanic vent that maybe didn't exist on Mars.
Yeah, or it could be something like the moon, or like
the moon,
the existence of the moon, or like.
Well, one of the leading theories about the origin of life, a lot of the most primitive organisms are thermophiles, and they're the most deeply branching. And so there's been a kind of theory for a while that the origin of life started in a hydrothermal vent in a deep sea
hot
hydrothermal vent, potentially on Mars, because it has a very different geological system. It doesn't have like long ocean ridges that have deep sea vents necessarily in the same way in the Noachian
most
period.
of the heat, as we were saying, is coming out through Tharsis, which is elevated. It's not in an ocean.
And so potentially that mixture of volcanism and water chemistry might not have happened in the same way on Mars, and that might be one of the things that you require to start a biosphere. And so Mars may not have had that opportunity because it didn't have that makeup. It doesn't have tectonics. It doesn't have these types of things. Having said that,
yes,
we didn't have tectonics before life started on Earth, but we did have vents still.
Yes, we did.
It might not have had those types of situations. Might not have quite been the same on Mars. It might not have had.
That's a very good point. Yeah,
as much opportunity as many like underwater vents, maybe.
Yeah, and of course it could just be that life on Earth was like a chance event. It's like super unlikely.
Or it could just be a statistically incredibly rare thing. And that.
And just because of like the anthropic principle, like observer selection, it seems like it would be common everywhere because because we don't want to think of ourselves as being particularly unique and special because everything. But the fact that we're sat here talking about it, wherever that life is however rare it is, that life's going to end up thinking about it and talking about it. So like that's what the anthropic principle is all about. It's quite a hard concept to kind of like talk about, but
if you're the one in a million. And you only know of your one, then it seems like it's unlikely that the other million are going to be the same as you, whereas actually you're that very very specific, very rare example. And it's possible we would get a very definitive answer to that by discovering life on Mars. If we didn't discover life on Mars, then we'd get more of an understanding of how maybe we're rare, or maybe there's something unique about formation of life on Earth.
Yeah, so if we did discover life on Mars and it was separate origin from ours, that could potentially, and we've talked about this before, but that could potentially be really, really bad news.
Yeah.
As well as it being like a massive like discovery and scientifically valuable, it could mean that life is very common, So if we take our discussion back to what we talked about way back, loads of episodes ago, about the Fermi paradox.
Oh yeah.
And about the fact that we don't see other intelligent civilizations out there communicating.
No.
It could be, if we find life on Mars, it would suggest that microbial life, like simple life, is very common, but that something stops intelligent life from emerging. So that there could be something in our future that's gonna kill us.
The great filters in our future.
Yeah, exactly. Yeah.
Well, it just takes down one of those barriers.
Yeah, exactly.
So one of the potential great filters. So
which would be the origin of life.
The origin of life.
So it would make the origin of life really common, like less rare, and push that great filter further forward.
Yeah.
Which could be a AI brain in a jar.
Yes.
Scenario, maybe.
Yes.
I don't know.
Yeah, I mean, I wouldn't be. Yeah, we're not going to go into the Fermi paradox too much, but yes, I mean, there obviously are other great filters, like the development of intelligence could take a very long time, was very rare.
Yeah.
And life starting maybe isn't that rare, so it doesn't. It's not like an absolute be all end all. I don't think.
No, it's not. No, it's just sort of removes one of the
big potential great filters that means that it's more. It increases the chance that great filter is actually in our future.
And I remember when we were speaking about this on the episode about the Fermi paradox, we decided that the origin of life is probably the most likely great filter. I think we did. Maybe not. I think that's what I think. I'll have to think about it again.
Yeah.
But I'm pretty sure that's what I think. But
the thing is that.
So if we did find life on Mars, it removes that. It suddenly makes.
I think we decided that it was probably in our past, didn't we?
Yes. So either origin of life or
because it seems like the origin of life took less time to start to develop in terms of on Earth than to get from the origin of life to an intelligent organism.
Yes.
Well, it definitely took a lot fucking longer.
So it's either the origin of life is a great filter itself, or just having
a biosphere that survives
for enough time to get to this point. Is very, very rare.
Yeah.
But anyway, so again, finding life on Mars or finding evidence that Mars was habitable but never supported a biosphere. Both of those things will help us narrow down that conclusion.
Like, why are we alone?
Yeah.
Type.
Yeah. Exactly.
Yeah. Definitely. Yeah.
Yeah. So another thing that's probably worth talking about, a thing that gets brought up quite often actually is all of this stuff we've been saying about habitability, about whether Mars could have supported life and all this stuff, is all based on what we know about life on Earth. So it's the conclusions, and it's all extrapolated from the terrestrial biosphere. And people say like, oh, what about forms of life, lives that we don't understand, like lives as we don't know it?
Yes.
Yes.
Well, I mean, we've talked about this, I think, possibly before.
Yeah, I think we have.
Past episode. It's worth briefly mentioning it again, in that there are good reason to suspect that certainly life in the way it develops is going to look similar, maybe using the same type of like a carbon-based life, is potentially going to be the same maybe throughout any life in the universe.
Yeah,
because of the way carbon as a molecule speciates into lots of different types.
Yeah.
You don't get that same type of chemical kind of speciation and things in things like silicon. They tend to form crystal structures and whatnot.
Silicon can form a lot of molecules, but the thing it forms when it combines with oxygen. It's like super stable.
Yeah, that's what I mean. So it forms crystalline structures.
Yeah, exactly.
Whereas carbon doesn't. So there's lots of reasons why you might suggest that actually life elsewhere in the universe might look like life on Earth.
Yeah.
It might look like superficially very different.
Yeah.
But actually, I mean, maybe it could even be that DNA is rough. It evolves in the same way with DNA every time. That would be a crazy thing, but it might actually have to. It might have to be the only information carrying molecule you can use to create a system that we recognise as biology.
Yeah, like natural selection is an extremely powerful optimizing strategy, basically.
Yeah.
So it's possible that some of the really basic features of biology on Earth are accidents, like frozen accidents.
Yeah.
It's possible, but it's also quite a strong argument that like the way things are like this because that is the way that you have to do it.
Yeah.
Like
they physically cannot work without.
Yeah, or if there are other strategies that are similar, they just get completely outcompeted by this strategy.
Yes.
DNA, protein, whatever. That's kind of like format. That's not to say that obviously, you might get different genetic code maybe or
you might get
whatever.
Exactly.
But very broadly speaking, it's quite likely that
it's quite likely that things are going to be carbon based, and then it's also quite likely that that they're going to be using an information carrying molecule that looks something like DNA.
Yeah, that's the thing. Like, so water is very good at promoting chemistry.
Yeah.
Carbon is a unique element in the way that it forms like so many ridiculous numbers of compounds that are all like reactive, not too reactive.
Yes,
that's the thing.
Like semi-stable.
Yeah,
they're exactly what you want for a dynamic biological system.
And the silicon thing, like the silicon-based life thing, we are sat on a giant ball of silicon.
Yeah,
and we're not made of silicon.
No. I mean, people have talked about things that are carbon-based, like methane in cells. Not methane, liquid methane on Titan.
Yeah, it's like instead of water, like a solvent.
And what was the other one as well? Hydrogen peroxide as a solvent for life. I mean, those things
and ammonia, I think,
ammonia as well.
Yeah.
I mean, maybe those are other ways you could do it with different temperature regimes and stuff. And we obviously don't have any evidence to suggest either way. But it's not ridiculous to suggest an environment like Mars that is not going to have those features like liquid ammonia and whatnot. It's got, it had temperatures and stuff similar to the Earth. To suggest that actually when you have that given environment that's similar to the Earth, that it would actually evolve in a sort of analogous way, at least a similar way, and that actually, I mean, it may not even end up looking that different at all, or it may look very different, but actually fundamentally there's some parts of it that are still quite close to what we found on Earth. We don't quite know how far down those levels it would go, like what levels it would look similar at, whether it goes right down to the molecular stuff, or actually, it's just
so the question is like what aspects of the biosphere on Earth, like limits of life and stuff, can we extrapolate and can we use to say like general universal rules that we can then apply to other planets like Mars, and that's what it's. I mean, that's a question that we don't have an answer to, and that's a question that we're trying to answer. Like what aspects is this temperature barrier, for example, temperature barrier for life? Is that actually like a fundamental limit? Like above that, carbon chemistry just doesn't work in the same way, or is it just that on Earth, evolution just hasn't explored like higher than that? That's a question that we have to try and answer. But it certainly seems that the like a carbon-based biosphere would be like constrained to certain sets of conditions.
Yes.
Universally.
Yes.
And
the chemistry is the same everywhere in the universe. Like it doesn't change. The periodic table doesn't change when you go over to 50,000 light years away or whatever.
Yeah.
As far as we know.
And
it shouldn't do.
The other thing is obviously that we only have the Earth's biosphere to use as a template for
assuming this.
Yeah. So things like talking about life as we don't know it, well, we're just completely in speculation there, basically. So in terms of like useful, like scientific, like testing hypotheses and looking for life on other planets, like this is what we have to work with at the moment.
Yeah. It's there's only so much use you can get of sort of saying, well, it could be anything. It's not really useful for, like you said, hypotheses, for discourse. Yeah. In these types of scenarios, but it's still useful to think about and consider as an alternative option.
Absolutely, yeah.
But in terms of this particular example, we think about life on Mars. It's probably going to be considering the similar scenarios, similar environments between early Mars and early Earth. They're probably going to match up somewhere.
Yeah. Given that Mars had environments that weren't even like near the limits of life. In the ancient past, the environments on Mars were just like standard like clement, like really nice, fine, like little lakes that you could have a swim in and be fine. Like so. So for that, we know from the example of the Earth that that's habitable. So